Students, welcome to GK Pillai's Maths classes, class 10. The chapter Tangents to a Circle has some easy questions. At the same time, you will find some tough questions also, mainly the two examples and 3 to 4 exercise questions. In the board exam, there is a definite possibility that in addition to a theorem, one of the difficult questions may be asked as it is. I have kept this in mind while preparing this video. So watch this video full now and also before your upcoming exams. There are many board examination questions that will find a place in my future videos. My efforts in reaching you, the student community, will be of use only if you subscribe to my channel. Please do that. This is the definition of a circle. You won't be asked in the exam, therefore you don't have to give much importance, just for understanding only. There are other terms related to the circle: chord, segment, sector, arc, etc. This also you will come to know. Now, when a circle and a line are given in a plane, there are three possibilities. One, the two may not intersect. So no common point, no intersecting. Here, if the line is intersecting the circle at 2 points, there are two common points. This is called the secant of a circle. The third one, the circle and the line are touching at a single point. This line is known as the tangent to a circle. That's what we are going to learn this chapter. Here we are discussing the two main theorems of the chapter. The first one, the angle between the tangent and the radius is 90 degrees. But the statement goes this way. The tangent at any point of a circle is perpendicular to the radius through the point of contact. When you are writing the theorem, you have to write the statement as it is. You cannot make your own statement. That's the most important thing. There are many sums based on this one, because since it is 90 degrees, applying Pythagoras theorem, you will have to do many sums. The next one is the length of the tangents drawn from an exterior point to a circle are equal. You have to show that PA equal to PB. And there are many sums based on this one. And proving them, it's very easy. It's given in the textbook in the proper way. That is why I have not included the answer in my video. But I can just discuss for your sake. When you take up these two triangles, actually these two triangles are congruent by RHS as well as SSS. Here we will make use of RHS. Since these two angles are equal, these two are radii and OP is common. Therefore, the two triangles are congruent, hence PA equal to PB. That's what you have to prove here if the theorem comes in the exam. This is a textbook question. The difficulty comes in understanding the statement properly. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Here we have to show that angle APB plus angle AOB equal to 180 degrees. That is the angle between these two tangents and the angle subtended by the line segment AB, which is joining the 2 points of contact and is subtending the angle at the center. The question is very easy. You can do it very easily. Now let us take this quadrilateral APBO. These two angles are 90 degrees each because the angle between the tangent and the radii. Therefore, in quadrilateral OABP, this angle plus this angle is 180 degrees. So this is known as cyclic quadrilateral. In a cyclic quadrilateral, both the pair of opposite angles make 180 degrees. So this angle plus this angle is 180 degrees. This is another important sum, not so difficult. Here what is given? There are two circles, concentric circles with center O. AB is the chord of the larger circle and the tangent to the smaller circle, touching the smaller circle at P. Let us join OP and OA. Here this angle is 90 degrees. Therefore, we can consider triangle OAP as a right triangle and apply Pythagoras theorem. We are having OA 5 cm and OP 3 cm. Applying Pythagoras theorem, we will get AP to be equal to square root of 16, 4 cm. And you should remember last year's theorem. Perpendicular to a chord from the center bisects the chord because AB is the chord of the larger circle. So OP is perpendicular to a chord from the center bisects the chord. So AP will be equal to PB. And both are equal to 4 cm. AB equal to 4 plus 4, 8 cm. This is a very important question. There are two questions of the same type. Here, the first sum ends here. In that sum, it is given that this is a quadrilateral, but here it is given as a parallelogram. That is the difference. There is a parallelogram touching a circle at 4 different points. We have to show that this is a rhombus. First of all, we will write tangents to a circle from an exterior point are equal. Therefore, we will write AP equal to AS, BP equal to BQ. Then you write DR equal to DS and CR equal to CQ. The way we are writing, these four should come on the same side and these four on the other side, so that when you add them, proper pairs will be made. Here, we are adding column wise. We will get AP plus BP plus DR plus CR on the left side and these four on the right hand side. In the beginning itself, put it in bracket, put these two in brackets. But here you have to organize it, AS and DS together and BQ and CQ together. Next step, you will get AB plus CD equal to AD plus BC. Here, in this particular sum, we have to go further saying it's a parallelogram. ABCD is a parallelogram. Therefore, AB equal to CD, opposite sides of a parallelogram are equal, and AD equal to BC. So we will replace this CD with AB and BC with AD. So we will get AB plus AB equal to AD plus AD. 2AB equal to 2AD or AB equal to AD. Now in this parallelogram, one pair of adjacent sides are equal. Therefore, this has to be a rhombus. This is another important sum. It's a bit tough sum only. But if at all they are asking in the exam, they will not change the things. They will ask as it is only. Try to understand this way. Here, a circle is given and there are two parallel tangents, x, y and x dash, y dash. Another tangent AB is drawn to this circle intersecting xy at A and x dash, y dash at B. You have to prove that angle AOB is 90 degrees. This angle is going to be 90 degrees. It should come to your mind, these two triangles are congruent by RHS as well as SSS. SSS means these two sides are equal. Tangents to a circle from an exterior point are equal. OP equal to OC, radii. OA equal to OA common. So two triangles are congruent by SSS. But I am using here with 90 degrees. These two angles are 90 degrees and OP and OC are radii and OA is common. Therefore, the two triangles are congruent by RHS. So, angle 1 equal to angle 2. You don't have to write fully for this. You just write these two triangles are congruent similarly. Therefore, angle 3 equal to angle 4. We got angle 1 equal to 2 and 3 equal to 4 here, CPCT. Now, since the two lines are parallel and AB happens to be a transversal, sum of these two angles is 180 degrees. Interior angles on one side of the transversal. And that is nothing but angle 1 plus 2 plus 3 plus 4 equal to 180 degrees. But we have already proved angle 1 equal to 2 and 3 equal to 4. Therefore, replace 1 with 2 and 3 with 4. Twice angle 2 plus twice angle 4 equal to 180 degrees, or angle 2 plus angle 4 equal to 90 degrees. Now let us come to triangle AOB. In triangle AOB, angle AOB plus angle 2 plus angle 4 equal to 180 degrees, angle sum property of a triangle, and substitute angle 2 plus 4 to be 90 degrees. Therefore, angle AOB becomes 90 degrees. When I have explained you this way, I think it should be easy for you. It's not that difficult. Now, this is a textbook example. Here, TP and TQ are drawn tangents to a circle center O from external point T, and you have to prove that angle PTQ. This angle is equal to twice angle OPQ. What we will do, we will take up this triangle. First we will keep this angle to be theta. Now TP is equal to TQ. Tangents to a circle from an exterior point are equal. Therefore, triangle TPQ becomes isosceles. If this is isosceles, then these two angles are equal. These two angles are equal. Now, in triangle PTQ, sum of the three angles is equal to 180 degrees. So if you consider this angle equal to theta, then sum of these two angles will be equal to 180 minus theta. But these two angles are equal. Therefore, both the angles become 90 minus half theta. Sum of these two angles is 180 minus theta. But if you are considering only one angle, it will be half into 180 minus theta, that is 90 minus half theta. Now, OPT equal to 90 degrees, angle between the tangent and the radius. So, angle OPQ will be equal to angle OPT minus angle TPQ. 90 degrees minus 90 minus half theta, whatever you got here. Open the bracket, 90 and 90 goes, you will get half theta. Now you replace theta with angle PTQ. So OPQ is equal to, this OPQ is equal to half of angle PTQ. So angle PTQ will be equal to twice angle OPQ. This is what you have to prove. That is the end of this video. You will find other videos discussing the fundamentals and board questions of other chapters in my channel. Don't forget to subscribe my channel and give a like to this video. Share it with your friends and tell them to subscribe to my channel.